In this example, we are going to show how to do linear regression using Google Sheets. So if you haven't already opened up fresh Google Sheets and Google Docs, that's what you need to do first of all. So I've got a blank Google Sheet open in one window, and the example that we're going to work on is this example from the slide over here, where we've got two variables, X and Y, that are relating to health insurance of different companies that have different number of employees. So X is the number of employees in the group plan of that employer, and Y is the average administrative cost being measured as a percentage of claims. So what percentage of people had claims. And so what we can see is going across the top row of the table are the different values for X. So one company had 3 employees, one had 7, one had 15, and so on. And for each of those companies, we have recorded Y, which is the cost as a percentage of claims. So for the group of 3 people, the cost was 40. For the group of 7 people, it was 35, and so on. So in order to use Google Sheets, first note that although this table is given to us where each row corresponds to a different variable, so the row 1 has all of the values of X and row 2 has all of the corresponding values of Y, when we use Google Sheets, we're going to need to enter the data as a table where each column corresponds to a different variable. So going over to Google Sheets, I'm going to let column A correspond to the values for variable X, and column B the values for variable Y. So I'm going to put those labels in. And then I come over, and so what I could see is that where for 3 employees the cost was 40. So when X is 3, Y is 40. And so I need to be sure that I enter the data as pairs of values consistent with how we have it given to us in the table here. So for 7, it was 35, and I would go through the rest of the values. So when X was 15, we were told that Y was 30. When X was 36, Y was 26. When X is 72, Y was 18. So first I need to enter the data carefully, again, where each variable is listed down a separate column. Now I'm going to create a scatter plot. So I'm going to highlight the cells A1 over to B6, where both the title of the data, so the labels X and Y are included, and the values. I'm going to go over to Insert at top, and I'm going to insert a chart. And by default, Google Sheets has created a column chart, which is not at all what we want. So in order to change the chart type, I'm going to come over to the chart editor on the right side of the window and change the column chart to a scatter plot. So I clicked on column chart. All of these options appeared. I'm going to scroll down, and here's the scatter plot that we want. It's called the scatter chart in Google Sheets. And now we've got our scatter plot. But there is no linear regression fit towards this, and there is therefore no equation or R-squared value. So in order to add a trend line or a linear regression, I'm going to go over to Customize in the chart editor and choose the series drop down. And if you're looking at series over here, there's an option to add a trend line. So we're going to check this option to add a trend line. And now you can see that the line, this is linear regression, has appeared, but we don't have a label for the equation. So in order to add a label that has the equation, I'm going to come over to Label down here, and rather than None, I'm going to choose Use Equation. And now we can see the equation appears over here, kind of in the legend of the chart. And in order to get the correlation coefficient, I'm going to check the option which shows the R-squared value. So now over here we have the equation for the linear regression, and we have what's called the R squared value, which is not the same as R, the correlation coefficient. So the first thing to note is the equation, I'm just going to type it out up here, would be y is equal to minus 0.284x. So our slope is minus 0.284 plus 37.4. So that's our y-intercept. We have what's called the R squared value, which is 0.914. Okay, but this is not the correlation coefficient. Okay, and we can know that for sure because here, as we move to the right, the dots go down. So this is a negative association between x and y. And when we have negative associations, we should get a negative correlation coefficient. So what the R squared value is it equals the correlation coefficient squared times itself. And so that's why when you multiply a negative correlation coefficient times itself, we get this positive R squared value. So to calculate the R squared, the correlation coefficient R, I'm going to do some scratch work over here. We need to take the square root of the R squared value first of all. And so you can do this on a calculator, but since we have Excel open, the way to take the square root of a number is to type the equal sign. Since we are entering a formula, the square root function is sqrt, and then in parentheses I can either click on the cell where that number is, or I could type in the number that I want to take the square root of. So in this case, I want to take the square root of the R squared value 0.914, and that tells me what the square root is. And over here we need to adjust the sign since there is a negative association. So the correlation coefficient R is going to be minus 0.956. We can round it off there. So the correlation coefficient should be negative. So if we just highlight these important things, there's the equation and there is the correlation coefficient. If you have an example where you have a positive association, so the dots are going up as you move to the right, you would still take the square root of the R squared value, but you wouldn't adjust the sign like we did here. So that's it. That's how you get a scatter plot, the formula, and the correlation coefficient for the linear regression.